Hello everyone, my name is Sarah Photowat. I'm going to cover AWS Redshift service demo in this video. This is as part of my final project for Johns Hopkins University and the course of Principle of Cloud Computing AWS. What am I going to cover in this Redshift demo? First, I will create a Redshift cluster and configure it. Secondly, I will load sample data to S3 bucket. Then I will load that data from S3 to Redshift. Then I will query Redshift cluster and do some query optimization. At the end, I will create Redshift snapshot and delete the cluster. Let us create an Amazon Redshift cluster. From AWS main menu, go onto the database section, click on Amazon Redshift. In the Amazon Redshift dashboard, click on Clusters. In the Clusters menu, click on Launch Cluster. In this screen, we need to provide a unique cluster identifier. I chose it to be Sarah Redshift Cluster. For database name, I provided dev. For database port number, I left it as it is. By default for Redshift, it's 5439. For master user name, I chose admin. You can choose anything you wish. And for master user password, I provided a password that needs to be combination of one uppercase, one lowercase, and one number, and confirm the password. Then I hit continue. In this screen, for node type, I chose DC1 large. For cluster type, I made it multi rather than single. And for number of compute node, I chose 4. Then I pushed continue. In this screen, I accepted everything as default. I'm not planning to do any database encryption, so at this point it is none. It can be changed in future. For the VPC, I chose the default VPC that was offered in this screen, and associated with that VPC there is a security group that I need to note it down because later on I need to go and modify the entrance so we can get to it from outside. This screen is the confirmation for all the options that I have chosen for my Redshift cluster. It also shows the on-demand hourly rate for this cluster will be $1. At this point, I hit the button Launch Cluster. This screen shows that my cluster is getting created. It's going to take 2 to 5 minutes. The most important things that we need to pay attention in this screen is we created our cluster in Oregon. We have to make a note of it because later on when we create the S3, we have to make sure that S3 has to be in the same region as our Redshift cluster so that we don't get cross-region latency and charges. In this screen, the Redshift cluster that I just created and I named it Sarah Redshift cluster is in the creating status. It's going to take 2 to 5 minutes as I mentioned, and in the meantime we can go to the security group of the default VPC and change it in such a way that we can access to it from outside. In this screen, I went to AWS main services. I clicked on VPC. I am in VPC menu. In VPC menu, I clicked on security groups. I identified the security group that I noted down, which is the security group for my VPC. I went to the inbound rules. I added a new line, Redshift, TCP, and port range 5439, which is for Redshift, and I opened it to the world. Under IAM service, in the group menu, I created a new group called Redshift group. The permission that I assigned to it is Amazon S3 full access and Amazon Redshift full access. Whichever user which is part of this group will have full access to the S3 bucket and full access to the Redshift. Under IAM service, under user menu, I created a user called Redshift user, and I also created access key and secret access key for this user. This user is assigned to a group called Redshift group that I will explain in the next slide. In this screen, under IAM service, under users, we click on Redshift user and we assign it to the Redshift group. Therefore, all the privileges that we define under Redshift group will be granted to Redshift user. Now I'm back in the same screen that I created the Redshift cluster. The status of the Redshift cluster is available at this point. To configure it further, such as configuring the JDBC or ODBC, we need to click on the name of the cluster, which is hyperlink. In this screen, under Configuration tab, we can see all the information about the Redshift cluster that we just created. We can scroll down and configure the JDBC. In this screen, we can use JDBC URL or ODBC URL. In my case, I would grab and make a copy of JDBC URL that later on I will use it for configuring SQL Workbench. Redshift also provides the JDBC driver that we need and the version of our choice. I have chosen JDBC 4.1 and I downloaded it so that I could configure SQL Workbench on my computer. Here I provided the instruction on how to install SQL Workbench and configure JDBC. As attachment, I've also provided a series of screenshots showing the steps. Here is the final screenshot that shows I added Redshift JDBC URL to the SQL Workbench connection profile. Here I am creating a S3 bucket and I named it Redshift S Photowat. This S3 bucket will be used to load sample data to it. Later, this data will be copied from S3 to Redshift. Here I created a folder called Data Load under my newly created S3 bucket. Here is the instruction for downloading sample data provided by Amazon and preparing it to be uploaded to my S3 bucket. In this screen, I uploaded all the data files to my S3 folder Data Load. Now I will create a sample data warehouse star schema based on popular customer part supplier relationship. Its fact table is line order. It's surrounded by 4-dimension part table, supplier table, customer table, and DW date. Here are the DDLs for creation of the tables provided by Amazon as a sample star schema. This is the SQL Workbench user interface, and we are running our queries inside Redshift connection profile. If you recall, we configured it before. I executed the DDL for creation of part table, and here it shows that it's got executed and it took about 18 seconds. In the same fashion, I created the other 4 tables. Through this query, I can tell that all of my 5 tables have been created. We can see that customer, DW date, line order, part, supplier are there. Now that our 5 empty tables are ready, we could run the commands to copy the data from S3 to these tables stored in Redshift. As you noticed, I have copied XXX over my actual access key and secret access key. If you recall, when I created my Redshift user, I downloaded these two keys. Here is the execution of one of these copy commands in SQL Workbench. The bigger the table, the longer it took. I have copied data to all of my tables. After I finished copying all the data from S3 to Redshift tables, I queried the table counts and they are all show that they are being populated. The biggest table is line order with 600 million rows, and it took about 10 minutes to get copied. I tried to retrieve all the 600 million rows from line order tables. Even though this was a bad full table scan query, I just wanted to see how Redshift behaves. While my long query was running in SQL Workbench, I went to my Redshift cluster configuration page and clicked on Queries tab. It showed that query 117.145 was in running status. Then I clicked on Query column, hyperlink, in order to drill down to know more detail about my running query. I was able to see all the information about this query, including start time, status, and even more. It also showed the stats like CPU utilization, network receive throughput, etc. I let the query run for about 38 minutes, and finally I aborted this SQL query. When I queried customer table with 3 million rows, I was able to get the result back in 49 seconds. I tried to run a query that is very complex. I called it Q2 with so many joins. The response time for this query was 14.92 seconds. I tried to run another complex query called Q3. I noted down the response time on this query, which is 20.66 seconds. I will try to optimize my table distribution style in order to improve the response time in future slides. Now I dropped all my tables. I recreated the table with these DLLs. However, this time I added distribution style, distribution key, and sort key based on investigation on typical queries, joins, size of the table, and nature of the data. As I mentioned in my lecture, Amazon Redshift distribution key and sort key are a powerful set of tools for optimizing query performance. On the other hand, setting a distribution or sort key that is not well thought out can even worsen query performance. In here for table part, the primary key, part key, I have chosen sort key and distribution key. For create table supplier, on the primary key, supplemental key, I have chosen a sort key, and the style, distribution style for this table is all. For customer table, I chose distribution style to be all. For DW date, I chose distribution style to be all and also made DDate key to be sort key. In line order table, I made IO part key, which is a foreign key from part table, to be a distribution key. In order to choose the right distribution key, one needs to pick a few important queries that needs optimization. It's important to know that we cannot optimize our tables for all type of queries. As it's shown in this screen, based on foreign key in the fact table, we chose the distribution key columns as well as sort key columns. Now that all of our tables are recreated with distribution key, I copied data from S3 to all of my tables again. For the sake of demo, I am only showing the copy command for part table. While my copy command is running on SQL Workbench on my Redshift cluster configuration page under Queries, all copy commands are getting analyzed and their runtime is getting captured. Now that all of the tables are populated, let us run Q1 query. This time, the query time reduced to 0.08, which was a significant improvement from 12.37 seconds. After I ran Q2, the query time reduced to 0.24 seconds, which was a significant improvement from 14.92 seconds. And Q3 runtime reduced to 15.34 seconds, which was a significant improvement from 20.66 seconds. However, 15.34 seconds still is a high number. When we run the same query for the first time, it takes longer for compile time on the leader node. I ran the Q3 for the second time. This time the query time reduced to 0.16 seconds, which was an amazing improvement from 20.66 seconds. Here is a query time before and after optimization. You can see a huge difference after we added the distribution key and distribution style to our tables. Now that all my data is loaded, I've decided to create a snapshot. In order to do that, I went back to Redshift cluster. Under Configuration tab, I went and clicked on the Backup button, and then I clicked on Take a Snapshot. I provided the snapshot name and pushed the Create button. The most important things about snapshots is, now that I have created a snapshot out of my cluster, in future, if I want to create a brand new cluster which has identical data, I can use this snapshot. At the end, I decided to delete the Redshift cluster that I created. So under the cluster menu, the cluster that I created is listed. I clicked on the cluster drop-down and I clicked on the delete cluster. In this pop-up before deletion, it gives us another option to create yet another snapshot. I provided a name, I said yes, and I clicked on the delete button. In summary, I created Redshift cluster and configured it, which included creation of 4-node Redshift cluster, updating VPC security group for external access, and creation of IAM Redshift user and a Redshift group. I also loaded sample data to S3, which included creation of a S3 bucket, downloading sample data, and loading data to S3. I also loaded data from S3 to Redshift, which included creation of tables and running copy command. We also query Redshift cluster and query optimization, which included running complex query and noting the runtime. Again, recreating the tables with distribution key, sort key, and copy the data to the tables. Running same queries again and note the optimized runtime. At the end, we compared the runtime before and after adding distribution key, and we saw the significant changes. Toward the end, we created the Redshift snapshot in case we need to recreate another Redshift cluster based on the same data, and then we deleted the cluster.